Oh, okay.
And then make sure you got coarse and feldspar. So the coarse is sort of the milky stuff.
So this is pegmatite. Grab it. Brand it.
Yeah, exactly. So yeah, this would be. So what happens?
Right.
There is. Those jointings are basically following the bottom of the tunnel. So as this point comes, it's popping up like this. Because you have words in this level. It's just a little down. It's kind of core of jointing, more like foundation. About sigma 1, stuff will recrystallize, and it will do so along sigma 3.
Right.
Right? So you get that pattern, tells you what the stress reaction is. But you get that pattern because you're basically destroying and recrystallizing the mineral face inside the rock. And that's what gives that kind of schistose texture. And if we they're rattling.
He don't like us.
We can't find it either. All we hear is this rattle, like way up.
No step on snack.
So here we are on Lassen Peak. We're about 9,000 feet in elevation. If you look right behind me, we've got some nice lava domes over here. There's forming a very viscous magma that's kind of pushing up, but not exactly exploding, and it just grows into a large dome like that. Behind me, you'll see that we have Lassen Peak right over there. We're getting a little bit closer to the top. Around all over here, you can see some of the deposit from the 1914 to 1915 eruption. A lot of this is reticite. I have a sample of it right over here. Looking at about 63 to 68% silica. It's one of the 4 major groups of rock lava that we'll find down here. We also have andesite, basalt, rhyolite. On Lassen Peak, we're a little bit under a mile from the top, and we've spotted some nice igneous rocks with some vesicle bubbles in them. These formed while the lava was cooling as it flowed down the mountain. Over here, you can get kind of a better visualization for the direction of flow. So you can see that these bubbles are a lot more elongated, meaning that as the lava was flowing, it was dragging along the ground, and these bubbles were just growing and stretching out in this direction. So this block right here is horizontally as it flowed down the mountain. Right up here we can see we have some columns that are emerging from this slope. We're still at Lassen. You can see on the columns there's some yellow color popping out at you. That's sulfur deposits. We can get a close-up of it right over here. You can see it coming out. These little veins over here. And you can definitely smell it up here, I'll tell you that for sure.
Alright, so we are in the heart of Bumpass. As you can see before, we have one of the largest fumaroles in the world right here. Notice the color change, the blue and the chalk white, all due to the anaerobic extremophiles that live within here. Again, the smell is very pungent, very much a sulfur rotten egg smell. Alright, so we are up close at Bumpass. Notice the extreme sulfur-rich water. Definitely different than anything I've ever seen.
Hey, this is Nutman, and I'm here at Bumpass Held in Lassen Park. And you see in front of me one of the sulfur pools. It's about 200 degrees, and the acidic rate is somewhere around 4, which makes it kind of like lemon juice. Remarkably, you would not think anything could live in there, but that's not the case. There's actually at least 3 types of bacteria that live there, and they can survive in the pH levels down to around battery acid, which is amazing. And they can obviously survive the temperature of about 200 degrees there as well, which is, twice of what boiling water is. And you can see it is actually boiling out there from the bubbles. Scientists aren't really sure how they do this, but they do know that the cell membranes of these bacteria have like a bubble wrap pattern to their DNA. To the lipids that form the cell membranes. And other than that, they're not really sure how they survive these high acid levels and high temperatures.
A steam vent coming out of the solid ground. Well, it looks like solid ground, but it's probably not solid ground here. It's going to be very brittle and probably not very thick. But through that steam vent, you can see that we've got some native sulfur precipitating on the rock, which just shows you what a high sulfur content that gas has that's coming straight out of the ground here.
Alright, so what we see here are sulfate deposits. The orange and the orange and yellow colors are that way just because when the rock is wet, it gets a little more orange. When it's dry, it gets a little more white, and these are just the varying colors we're seeing.
So a lot of hot springs in the world. People really like to visit because they can actually get in them and enjoy them. But everything here is so acidic that even if it weren't boiling, you really don't want to get anywhere near it because it will definitely burn your skin with just the acid content in the water.
Monsters.
But the main kind of like fizzy texture is essentially the original texture from lava flow inside the tunnel. And again, this is an upper surface. So what this tells us is the tube was made by a flow of lava, which then kind of evacuated down to about this level. And this is the upper proper surface of the lava. So this is what the landscape above us looks like at scenic ground level. So it's covered with vegetation and so on.